Do you like to drive fast? Yes. And look, many of us do. We like feeling the wind in our hair, watching the world blur by, and experiencing the thrill of controlling a machine built for speed. It's just satisfying, isn't it? And then there are the daredevils of Formula One, hurtling around the track at hundreds of kilometers an hour with nothing more than a slim car shell to protect them in a crash. It is a magnificent sport that celebrates both risk and engineering. And within this arena, you'll find some of the most spectacular machines ever built. Formula One cars represent some of the most meticulously engineered and resource-intensive projects of our time. And today we're going to focus on a standout creation, the Mercedes-AMG W16. This machine is one of humanity's most remarkable achievements. And once you learn the story behind its creation and the attention to every minute detail, you'll see why it wasn't simply thrown together. It was painstakingly designed and built for a singular purpose: to race toward the checkered flag faster than anyone else. This car embodies what happens when a racing team and its talented engineers commit to winning at any cost. It's the result of transforming weaknesses into strengths and merging speed and precision with ingenious design. But is that enough to seize victory? Strap in and start your engines. We're about to find out, or as they might say in Formula One, it's lights out and away we go. At a crossroads, birth of the W16. So why did Mercedes need a new Formula One car in the first place? Well, beyond the fact that every team designs a new car each year to keep up with evolving strategies, technologies, and regulations, there was a deeper reason. By the end of the 2024 season, the Mercedes Formula One team found itself at a crossroads. Although Formula One regulations set strict guidelines for aspects such as power, shape, and safety, they also leave enough room for innovative designs to emerge. Designs that can change the game entirely. The last major technical overhaul of Formula One car manufacturing regulations came in 2022. And although there had been brief spells of success, a win here, a fastest lap there, the championship had continued to elude them. This experience stands in stark contrast to Mercedes' past. Before 2022, the team clinched 8 consecutive constructors' titles, a championship awarded to the team that accumulates the most overall points than any other, as opposed to counting individual drivers' tallies. Since the new regulations were introduced in 2022, however, their performance has been spotty at best, with only 5 race wins to their name. This decline and inconsistency eventually led to the departure of long-serving talisman and former world champion Lewis Hamilton. With just 1 year remaining until the new regulations take effect in 2026, Mercedes recognized that this was their final opportunity to shine with their current car design. The previous model, the W15, simply did not measure up. Don't get me wrong, it was fast. It was really fast, but several issues with the car contributed to its underperformance on race day. For starters, the outside temperature played a significant role in the car's performance, and any imbalances in the temperature of the different tires caused the car to handle and react differently from one session to the next. It might seem like a small detail, but when you're traveling at hundreds of kilometers per hour, even a slight increase in efficiency and reliability can make a massive difference. Now, the previous car was designed around optimizing a super low ride height. Generally, the lower the car is to the ground, the better it performs. A low ride height creates a low pressure underneath the car, often less than 3 centimeters from the track, which effectively sucks the car toward the ground like an airplane wing, resulting in increased grip without the need for a huge wing on the back that would increase drag. Aerodynamics is everything in this sport. The W15 was designed with this principle in mind. However, for bumpier tracks, the ride height had to be raised. This adjustment lowered the performance for the car more than it did for others. If the ride height had been left unchanged, the car could have become unstable or even damaged, an outcome you definitely want to avoid when traveling at speeds that might otherwise get you pulled over on the autobahn. Now, the car was prone to understeer in slow corners, hesitating to turn and disrupting the driver's preferred racing line, which in turn diminished performance. Coupled with issues like a low ride height and inconsistent performance due to temperature fluctuations, winning races on any given day was like blindly trying to hit a bullseye on a dartboard from the basket of a hot air balloon. It just wasn't very likely. However, the situation also revealed Mercedes' objective. The car was already fast, and if they could smooth out the flaws, a podium finish on race day might very well be within reach. With that goal in mind, the engineers set to work, designing and building what they hoped would be the car to restore Mercedes to glory. And the result was the W16. A new era. So, what design changes were made between the W15 and the W16 that promised to flip the game on its head, transforming Mercedes into winners? Well, if you're not into Formula 1, the W16 might seem like just another F1 car, a blend between a go-kart and a spaceship. However, side-by-side comparisons reveal significant design changes that had some Formula 1 enthusiasts practically frothing at the mouth when the car was unveiled in late February 2025 in London, just ahead of the new season. Technical director James Allison shared the team's vision for the car, stating, "Being the fourth year of these regulations on the chassis side, the cars are in a more mature phase. Big gains in lap time are harder to come by, but we've been focused on improving the areas that held us back last year." But what exactly has changed, and what makes this new design so unique? While the new car does adopt the W15's overall chassis geometry and suspension layout, almost everything else is entirely new. When you view the two cars side by side, it becomes clear that the bodywork has been completely re-engineered for aerodynamics, with modifications made to every aerodynamic surface. Although the suspension layout does remain the same, the front suspension has been completely redesigned, and additional changes under the skin have been implemented to address the flaws of the previous model. The issue with the W15 was that it was too extreme, exceptional in some areas but lacking in others. Mercedes' aim with the W16 was to retain efficiency while introducing a more harmonious set of traits to the new design, ensuring a more consistent range of speeds. Now, naturally, the more consistent a car is, the more quickly a driver can adapt to it over time. Picture it like riding a tamed horse versus a wild bull. Both are dangerous, both can reach high speeds and pose lethal risks. However, with one, you know what to expect, whereas with the other, it's completely unpredictable. In technical terms, the goal was to balance the downforce, the force pushing the car onto the track to increase grip, with the ability to reliably handle both high speed and slower, more technical corners. In theory, this balance makes the W16 a more well-rounded vehicle overall. You'll notice on the nose of the car particularly that it is noticeably narrower and lacks the usual slot gap, that small space that allows air to flow around it more easily and follow the path the engineers designed, resulting in a more predictable vehicle. Additionally, the scalloped out underside creates a negative pressure, which increases both airflow and downforce. Meanwhile, the absence of a slot gap largely accomplishes the same function, but actually enhances its effects. Technically, a slot gap is used to reduce turbulence, loss of downforce, and drag, all persuasive reasons for its implementation. So, why did Mercedes get rid of it? Well, ultimately it comes down to the old chestnuts of aerodynamics and physics. And let's be honest here, you can't claim Formula 1 isn't a sport for nerds, and, well, that's why I like it. Without a slot gap, more air is forced to travel through the car at high speeds rather than simply flowing around it. This increased airflow creates additional downforce on the front axle, which allows the car to navigate corners more safely and predictably, especially at lower speeds. At higher speeds, however, there is actually less downforce available for corners, a prime example of the many trade-offs involved in designing an F1 car. Since the key issue with the previous model was understeer in slow-speed corners, this modification directly addresses the engineer's concerns. So you can probably see what we mean when we say it results in a more well-rounded vehicle. So, this change does make the car less aerodynamic in some areas, and while that might have been a problem with the old design, the entire body has been reshaped to accommodate it. You might assume that this alteration would lower overall speed, since achieving stability through downforce in slower corners usually comes at the cost of extra drag. However, on straightaways, you don't need all that additional downforce, and the drag created by a stopgap is simply eliminated, reducing overall drag and allowing for higher speeds in these sections. The drag reduction system, or DRS, also contributes to this improvement. Now, in theory, the W16 can handle corners more effectively while actually reaching higher speeds on straightaways compared to the previous car, which is some pretty nifty engineering. Meanwhile, another change is the addition of a twin turning vane assembly near the wheels and front suspension. These two small devices capture the airflow forced around the inside of the tire as it rotates on the track and divert it to the void area behind the tire. This redirection reduces tire drag by preventing air from being pushed into the vehicle, especially underneath the car's floor, which can negatively affect performance at top speeds, ultimately enhancing the car's overall aerodynamics. The rear wing remains one of the few external parts of the car that is identical to the 2024 model. However, this is because it is a bolt-on component solely intended to generate downforce. Throughout the season, there will likely be several iterations of different wings, each tailored to the specific aerodynamic needs of the car for various tracks. The final significant change to the car's structure, as we've been told, centers on the carbon fiber used in its construction. In an innovative new design, traditional carbon fiber has been replaced with sustainable carbon fiber composites, marking the first time the material has been employed for building key components of a Formula One car. This new material is just as light and strong as conventional carbon fiber, yet it offers considerable environmental benefits. Overall, these composites make up 75% of the car's construction, a core element of the Mercedes team's commitment to achieving sustainability goals by 2040. The company believes that such innovations have the potential to extend far beyond motorsport, opening up opportunities to apply these developments in various fields, from aviation and aerospace to technical performance fabrics. Team principal and CEO Toto Wolff commented, "When you combine performance and innovation, you create progress. I am proud to lead a team of problem solvers who are committed to driving sustainable change." Let's hope the same drive translates to sustainable change on the track too. After all, when millions of dollars go into engineering a Formula One car, you definitely want those efforts to result in wins. How to build a monster. So, what can we say about the internal specs of the W16? What raw performance does it deliver? Well, let's break it down and see how each element of this machine has been meticulously engineered to maximize speed, downforce, and perhaps most importantly, safety. All this innovation goes hand in hand with reducing drag as much as possible, all in pursuit of that magical checkered flag and those subsequent champagne celebrations. And let's start with the engine, because without it, even the perfect car, well, it's not going to go anywhere. Modern F1 engines are surprisingly compact, designed to keep the power-to-weight ratio in check. However, their small size doesn't mean that they lack power. Take the Mercedes W16 F1 car, for example. It's equipped with a 1.6-litre turbo-hybrid power unit featuring 6 cylinders. Essentially, this is a V6 engine, similar to those found in many sports, muscle, and performance cars. Those cars tend to be much heavier than an F1 machine, and when you consider the impact of weight, you begin to understand where all the speed comes from. Although there isn't an official top speed listed for the W16, many believe that it can reach around 230 miles an hour, or roughly 375 kilometers an hour. It has a 90-degree bank angle, meaning the cylinders are positioned at a wide angle from the engine block. This design provides the car with better balance and a lower center of gravity, which are both crucial for cornering. The engine also features 24 valves, 4 per cylinder, which allows more air to flow into the engine for efficient combustion and improved performance. Despite its small size, this engine could generate significant power, reaching up to 15,000 revolutions per minute, a figure that is twice what a typical road car might achieve at its red line. The 15,000 RPM limit is set by F1's regulatory body, the FIA. Additionally, the engine uses a fuel injection system where specialized fuel is sprayed directly into the combustion chamber at over 7,000 psi. This enhances combustion efficiency and reduces emissions, with each of the 6 cylinders having its own injector for precise control. And then on top of all of that, you have the turbocharger, the exhaust turbine, and the energy recovery system, or ERS. The turbocharger uses exhaust gases to spin a turbine, which in turn forces more air into the engine through a compressor. More air means more combustion, and more combustion means more zoom time. The exhaust turbine is connected to the turbocharger and spins faster than a dentist's drill. It's designed to recover energy from the exhaust, which is then rerouted back into the car via the ERS. The system uses units that focus on kinetic energy under braking, similar to what modern electric cars do, and on heat energy, which, as you can imagine, Formula One cars produce in, well, abundance. That energy is then transferred into electricity that the car can use intelligently as the race progresses. This is what makes the engine a hybrid power unit rather than a standard internal combustion engine that you might see on the road. Inside the car itself is where the driver sits, in what we call the cockpit, the heart of the engineering marvel that is a Formula One car. The driver's seat, made from the same carbon fiber composite as the car's frame, is designed to be removable to allow access to other internal components. This choice of material not only keeps the frame light and strong, essential for achieving faster speeds, but also maximizes safety within the commercially available limits for Formula One development. Lower weight translates to faster speeds, and carbon fiber is one of the few materials that can deliver both performance and protection at these extreme velocities. The seat is equipped with a 6-point safety harness to prevent the driver from being thrown from the vehicle in the event of a crash. While it might sound counterintuitive, consider the outcome of a high-speed impact. Experiencing road rash at hundreds of miles per hour with nothing protecting you from a metallic barricade except a helmet would be a whole lot worse. Adding to the safety suite is the HANS device, short for head and neck support. This device is constructed from carbon fiber reinforced polymer and attaches the helmet to the rest of the driver's body. It provides a secure resting support for the head while keeping the shoulders and neck properly aligned. This is a critical safety feature. While many people might experience whiplash at normal road speeds, imagine the effect without such protection in a Formula One car. You could easily end up looking like Quasimodo after a crash. Or just dead. Essentially, the Hans device is a lifesaver that still allows for natural head movement. Also located in the cockpit is the detachable steering wheel made of carbon fiber. Once again, it's a bit of an unmistakable theme throughout the design. Around the cockpit and the base of the bodywork is what's known as the monocoque. And no, we're not talking about a singular chicken here. This is a crucial internal safety structure designed to house the driver and cockpit. It ensures lightness, speed, and safety in the event of a crash. And yes, you guessed it, carbon fiber. Think of it as a lightweight, rigid chassis structure that integrates the body and chassis into a single unit that protects the driver while also enhancing the car's handling through better cornering. Next, let's consider the bodywork itself. This carbon fiber composite covers all the major external elements of the car, which are designed to be aerodynamic. These include the engine cover, side pods, floor, nose, front wing, and rear wing. Now let's talk about suspension. When I mentioned that the W16 uses a carbon fiber wishbone system with push rod activated inboard springs and dampers, you might stare at the screen and wonder what the fuck I'm talking about. But this is all just really engineering jargon. In plain terms, it means that a carbon fiber rod connects the car's wheel to its suspension springs and dampers, helping drivers overcome bumpy surfaces more smoothly. Simple. When the car goes over a bump, the wheel pushes this rod upward. In the case of the rear suspension on the W16, the rod directs this force straight into the springs and dampers. For the front suspension, however, this motion is transferred through several mechanisms that guide it inboard toward the springs and dampers located in the nose. The term wishbone simply describes how the wheel is connected to the chassis by a suspension arm. This arm starts at the center of the wheel and splays outward in two directions, connecting to the rest of the vehicle in a shape that resembles a wishbone. And just like that, you now understand F1 suspension. The wheels are made from forged magnesium using a multi-stage forging process, which ensures they are lightweight yet strong enough to handle both high speeds and the demands of the track. They're typically a stock item in Formula One today and have been produced by the Japanese company BBS since 1992, when they first supplied wheels to the Ferrari racing team. BBS has served as the official supplier of wheel rims since 2022. The tyres are supplied by Pirelli, the renowned brand that has provided all F1 teams with tyres since 2011, though this agreement may be revised as early as 2027. The 18-inch tyres consist of 6 slick rubber compounds, ranging from the hardest, which lasts the longest but offers less grip, to the softest, which provides superior grip but wears out quickly, necessitating a pit stop sooner. For race day, 3 of these 6 compounds are chosen and color-coded to avoid any confusion. In addition, Pirelli provides each team with 13 sets of dry weather tyres. These include the 3 primary compounds mentioned earlier, as well as several sets of intermediate and full wet tyres to suit the day's track conditions. For steering its wheels and tyres, the W16 employs a power-assisted rack and pinion system. This system uses a hydraulic pump and pressurized fluid to help turn the car's wheels, which can be quite challenging to maneuver at high speed given the amount of grip and downforce. Anyone who's gone go-karting or experienced power steering failure in a car could appreciate that, or at least they can a fraction of how difficult it is to steer without some extra assistance. The term rack and pinion refers to the mechanism that enables the wheels to turn. In this mechanism, a pinion gear connected to the steering column rotates and meshes with a toothed rack, thereby pushing the wheels left and right when you turn the steering wheel. Pretty simple stuff. Gearbox comes next. 8 forward speeds, 1 reverse gear, which you never have to use mid-race. It's encased in carbon fiber for added protection. The brakes feature carbon discs and pads, and at the rear, a brake-by-wire system monitors the driver's pedal input, sending a corresponding electrical signal to the braking system instead of relying on mechanical connections. The calipers, the compounds that actually clamp down on the brakes, are crafted from a lightweight yet sturdy aluminium alloy forged from a single block, and they're nickel-plated to resist corrosion. This design helps maintain strong braking performance, which is crucial when you're traveling really quickly. Finally, among the main elements of the car, you have the safety features. We've talked about the cockpit and the monocoque survival cell, as well as the Hans device and the 6-point harness, but the rest of the car is also designed with safety in mind. The car includes what Mercedes refers to as penetration panels in the monocoque. These are engineered to prevent sharp parts of the car from penetrating the cockpit in the event of a crash. It's one thing to barricade at high speed, but it's another to be impaled by your own suspension rods. The car also incorporates crumple zones, which are designed to deform, absorb energy, and even break off during a crash. Made from carbon fiber, of course, these zones are very effective at their job. And finally, there is the titanium driver protection structure, also known as the halo, which prevents the driver from dying if the car flips over. Think of it as a mini roll cage positioned just above the driver's head. This feature has saved drivers' lives in circumstances where they might otherwise have been killed in a particularly severe crash. After that, it's largely minor components. Electronics, instrumentation, and the fuel system are all designed to ensure the car runs as smoothly as possible. Petronas is the well-known sponsor of Mercedes, and they supply all of the car's lubrication and fuel. And that's really all there is to it. You can see how meticulously the engineers designed every detail to ensure not a single gram of weight was wasted and that every ounce of power could be efficiently transferred from the engine to the wheels with minimal loss. And now you don't just understand how the W16 works, you also have the basic building blocks of how all F1 cars operate, as most cars utilize these same systems or variations of them. So, given that, how does the W16 stack up? Well, it's been engineered exceptionally well, with its main issues mostly addressed back in the W15 days. So, what can you expect whenever you see this machine on the track? A champion's car. The W16 has now been driven in several Formula One Grand Prix races for Mercedes. So, how's it performing? Well, all things considered, it's doing pretty well. Mercedes struggled in the 2024 season to get near the podium, and while McLaren is currently running away with the championship, Mercedes sits comfortably in second. This is especially impressive given that the team has lost a multiple world time champion from its driving lineup, a strong indication that the car is well designed and has largely overcome its predecessor's flaws, even if it's yet to win any races. Of course, it's still early in the season, and we won't fully understand how the W16 stacks up until we reach the end of the season and see who stands on the winner's podium. It's worth noting that McLaren, now in first place, is also using the same engine, albeit with different design elements in other areas, which serves as another strong endorsement for the engine's performance. In this sense, the fact that Mercedes is high up in the standings without a win is a testament to the W16's reliability and consistency, precisely what Mercedes intended. George Russell, one of Mercedes' drivers, has generally said that he likes the car and that it performs well on the track, albeit with one small bugbear. He mentioned that the car performs better in cooler conditions and that temperature continues to affect its consistency from race to race. While the understeer issue appears to have been fixed, which is really important, the temperature-related challenges are seeming to persist. Nonetheless, it's shaping up to be a strong season for Mercedes thanks to the skill of their drivers and the performance of the W16. In the right conditions, this machine can really fly. During the Japanese Grand Prix in Suzuka, Kimi Antonelli, the 18-year-old driver Mercedes chose to replace Lewis Hamilton, won the fastest lap, adding another early notch to the W16's belt. Now, it might not end up winning the whole championship, but it's quite likely that the Mercedes W16 will see its way onto the podium by the end of the season if it can maintain its current pace for the foreseeable future. Soon, the cycle's gonna begin anew again. With the start of the 2026 season, the FIA will enforce a fresh set of regulations that necessitate innovative car designs. Some might argue that it seems wasteful for Mercedes to redevelop their car so extensively this year, only to set it aside next year. If winning isn't guaranteed regardless, why not cut their losses and focus on pouring resources into the 2026 car instead? And that's a valid question, but elite sport just doesn't work that way. Toto Wolff addressed this very dilemma in an exclusive interview with Autosport, saying, "This is the crux of the matter every year, and especially if you have such a big regulatory change. Are you going to compromise one year or the other?" And at this point, we'd like to borrow a phrase from the late great driver Niki Lauda, which comes into play when confronted with this choice. Would you rather win this one or the next one? And his answer is both. Thank you for watching.